Welcome, my friends. You guys are probably so annoyed with me saying my friends, but I want you guys to understand every unit I will have a different theme, and for this derivative unit, it's my friends. Alright, so the thing that we really want to hit on is what's called the quotient property, but really what we want to get into is how do we take derivative of problems that involve division. So for example, okay, look at tangent. Well, I want to find the derivative of tangent. Well, first things first, we do know tangent is the same thing as sine over cosine. So that should be kind of a indicator to us. Okay, if I want to find the derivative of tangent, I maybe need to rewrite it as sine over cosine, but notice how there's a division involved. We don't know how to take derivatives when there is a division involved, and that's when we're going to develop what we kind of consider to be the quotient property. So let's take a look at the problems down below here. How could we critically think to solve a problem like this? Well, x to the fifth means that we have 5 of these on the numerator, and we have down below x squared, right? You cancel these out, we can just simplify it and we get x to the third. So this is all equal to x to the third. So now we know we got y is equal to x to the third. If we take the derivative of this, we're going to get 3x squared right over here. Okay, I did a simple problem like this to show you what we're going to consider to be called the quotient rule. Now the quotient rule, this one is just tough, and this is going to take practice, because really I forgot who perfectly invented this, man. They really had to think this through, and they had to really, I don't know, I would say probably just do trial and error, just like we did before. The way we're going to do it is we'll let the numerator be the first, and we'll let the bottom be the second. Okay, that's just the way you can think about it, but really it goes like this. You take the derivative of the top, or the first, very similar to the product rule, and then we're gonna leave the bottom alone, subtracted by, well, leave now the top alone, right? We leave the top alone. Then what do you think comes next? Derivative of what? Well, derivative of the bottom, all divided by, believe it or not, it's going to be the bottom squared. And we're going to get practice saying this over and over and over again. We don't need to write this rule down. So let's try it. We take the derivative of the top. So if I want to take the derivative of the top is 5x to the fourth times, we want to leave the bottom alone, minus, we leave the top alone. So leave the top now, right? Leave this numerator alone. Take the derivative of the bottom, which is going to be 2x, all divided by the bottom squared. Well, the bottom is x squared, so the bottom is x squared, and then squared. Let's simplify this. It's going to be 5x to the 6 minus 2x to the 6, all divided by x to the fourth. Okay, because they both have x to the 6's, we'll simplify like terms. 5 minus 2 is 4, 3, so we get 3x to the 6 divided by x to the fourth. 6 on top, 4 on bottom, they're going to cancel out, and we're left with 3x squared. So you can see this little rule, even though it seems like a lot of work, it's in fact going to get us the exact same thing. Now, of course, for a problem to the left, you could just do what we did, a little shortcut, but the algebra 2 simplified and then take the derivative. I just wanted to show you in a simple function how the quotient rule is still going to get us the exact same derivative. And the reason why this is helpful is because if we go to these problems down below here, okay, they're a little bit more complicated. And if we use the quotient rule, we can solve the derivative of this pretty nice. And the reason why is because, well, first things first, okay, what are we going to use? Well, I know there's a division involved, and whenever we see anything dividing, we got to use the quotient rule, which is what we did. So take the derivative of the top. Well, the derivative of x is just 1. Okay, so you can put it if you want, leave the bottom alone, minus, leave the top alone. Now take the derivative of the bottom, which just happens to be 1, all divided by the bottom squared. Boom, just like that. Okay, if you distribute 1 across, we're just going to get 1 times x, which is x, plus 1 times 2, which is 2. So you see, we don't really even need this 1 here because it's just 1. Okay, we do have this minus sign. Be a little careful, okay, because this minus sign is to everything. This is subtracting everything to the left. So let me just simplify this like such. Okay, boom, boom. And what we're going to get is x plus 2. Distribute the negative across, we get negative x. Distribute this across, you get negative 1 over the bottom squared. Okay, x minus x cancels out. 2 minus 1 is 1, so we get 1 over x plus 2 squared. And that would be the derivative of this function to the left here. Again, I can use the quotient property whenever you see a division. Whenever you have something on the numerator and denominator, you can use this trick. And we always consider the top to be whatever's on the top. Doesn't matter how many terms we have. So if we do the second problem here, we're going to get y prime is equal to, derivative of the top is just 1. Leave the bottom alone. Minus, leave the top alone. Now take the derivative of the bottom. Well, this is just going to be 2x. All divided by the bottom squared. Boom. Okay, 1 multiplied by this is just x squared plus 2. Okay, this right here, well, is going to be minus, let me put a parenthesis, well, 2x times x is 2x squared. And then 2x times 1 is plus 2x. Just like such. Okay, and I like to put parentheses there because if you don't, sometimes you'll make a minor algebraic mistake and think this subtraction is just on the first term, when in reality it's going to subtract everything. So that's why I like to distribute this out first before we do anything else. Now, last but not least, we're going to get x squared plus 2. Distribute this across. Now we get minus 2x squared minus 2x, all divided by x squared plus 2 squared. Because that's the bottom squared. X squared minus 2x is negative x squared. So gone, gone. Negative 2x doesn't cancel out with anything, so just minus 2x, and then we get plus 2. Boom, all divided by x squared plus 2 squared. Okay, and I'm hoping by now you're starting to get the hang of this. Maybe the hardest part is just actually simplifying through. So let's just go ahead and maybe do another problem to the left here. So, okay, I noticed there's something on numerator and denominator. That's going to signal to me that I have to take the derivative by using the quotient property. So it's just first being able to understand what type of problem this is. Okay, so if we go to do this, derivative of the top is just going to be 4. Leave the bottom alone. Okay, I'm leaving the bottom alone. Minus, leave the top alone, which is 4x plus 3. And now we take the derivative of the bottom, which is 2. All divided by the bottom squared. So the whole thing squared. Okay, that's going to be dy dx is equal to. So now we go dy dx is equal to, well, 4 times 2x is 8x. 4 times negative 3 is negative 12. Okay, 2 times 4x, let me put the minus sign, I'll put another set of parentheses, is 8x, and 3 times 2 is 6. Boom. Okay, now I'll distribute this across, and we're going to get 8x minus 12 minus 8x minus 6. You see how that negative sign is so important. It can lead to a serious mistake if we're not careful. 8x minus 8x cancels out. Negative 12 minus 6 is negative 18. So our final result, our final derivative for this problem, dy dx, is going to equal negative 18 over 2x minus 3 squared. Okay, let's go to the second problem here. Again, it's just a matter of practice, and we just got to memorize this rule. In the future, we can show you where it comes from. So take the derivative of the top. The derivative of e to the x is just e to the x. Leave the bottom alone. So 4x squared plus 2x plus 1 minus, okay, leave the top alone. So we leave the top alone, multiplied by the bottom. Well, the derivative of the bottom is going to be 8x by the first term plus 2. And we're going to get this here, all divided by 4x squared plus 2x plus 1 squared. Okay. Now, a problem like this, we're not going to simplify through on the AP test. I don't think we'd have a problem like this in particular, but that's just to show you just kind of how you would go about doing a problem like such. All right.